Have you ever wondered what actually happens when you type a question into ChatGPT? You type a few words, you press send, and within seconds you get a detailed answer. But how does that happen? Is ChatGPT searching the internet? Is a human writing the answer, or is something completely different happening behind the screen? The answer is fascinating. ChatGPT is an artificial intelligence system designed to understand and generate human-like language. But it doesn't think exactly like a human. Instead, it uses a large neural network that has learned patterns from enormous amounts of text. When you send a message, ChatGPT first breaks your text into smaller pieces called tokens. A token can be a word, part of a word, punctuation, or another small piece of text. For example, a simple sentence can be divided into several tokens. The AI then processes these tokens and looks at how they relate to each other. This is where one of the most important technologies behind modern AI comes in. It's called the transformer architecture. Transformers became extremely important because they can process relationships between different parts of a sentence very effectively. Imagine reading a paragraph. To understand the meaning of one sentence, you may need to remember something mentioned several sentences earlier. The transformer architecture is designed to analyze these relationships. One of its key mechanisms is called attention. Attention helps the model determine which parts of the input are more important when generating a response. For example, if you ask, "What is the capital of France?" the model needs to understand the relationship between capital and France. It uses patterns learned during training to determine what information is likely to come next. But here's something important. ChatGPT doesn't simply store a giant database of answers. Instead, the model contains billions of numerical values called parameters. These parameters are adjusted during training. They help the model recognize patterns in language. You can think of these parameters as a massive collection of learned mathematical relationships. During training, the AI is exposed to huge amounts of text. The model repeatedly tries to predict what comes next. For example, imagine the sentence, "The sun rises in the..." The model might predict east. If the prediction is wrong, the training process adjusts the model. This happens again and again, not thousands of times, not millions of times, but an enormous number of times across huge datasets. Over time, the model becomes very good at predicting language patterns. This process requires enormous computing power. Modern AI models can be trained using large numbers of specialized processors working together. These processors perform massive numbers of mathematical calculations. And this is one reason AI data centers contain huge amounts of computing hardware. Once training is complete, the model can be used to generate responses. This stage is often called inference. When you send a message, the model processes your input and begins generating an answer. But it doesn't generate the entire answer at once. Instead, it generates the response step by step. It predicts what token should come next. Then it predicts the next token, then another, and another. This happens extremely quickly. That's why you can watch a response appear on your screen almost instantly. But how does the model know what to say? It uses probabilities. For every step, the model considers many possible next tokens. Some may have a very high probability, others may have a lower probability. The system then selects an appropriate token based on the model's calculations and the settings being used. The process continues until the response is complete. This might sound simple. But behind every token are huge numbers of mathematical operations. And this is where powerful AI chips become important. The model needs to perform these calculations extremely quickly. Specialized processors can perform many operations in parallel. This allows the AI to generate responses much faster than a normal computer could using a simple program. But there's another important question. If ChatGPT is predicting the next token, does that mean it doesn't actually understand anything? This is a complicated question. AI models don't understand language in exactly the same way humans do. Humans have physical experiences, emotions, memories, and consciousness. A language model works through mathematical representations and patterns. It can produce remarkably useful and coherent answers because it has learned extremely complex relationships in language. But that doesn't mean it experiences the world like a human being. Another important part of modern AI systems is instruction following. A raw language model might simply continue text, but a chatbot needs to do much more. It needs to follow instructions, it needs to answer questions, it needs to maintain context, and it needs to produce useful responses. So modern systems use additional training techniques to make the model better at following human instructions. This helps turn a powerful language model into something people can actually interact with. Context is another important feature. When you're having a conversation, ChatGPT can use earlier messages in the conversation to understand what you're talking about. For example, if you first ask about AI chips and then ask, "Why are they so fast?" the system can use the earlier context to understand what "they" refers to. This makes the conversation feel much more natural. But context has limits. The model cannot necessarily remember everything from every conversation forever. What information is available depends on the system and the features being used. Now let's talk about something many people misunderstand. Does ChatGPT automatically know everything happening in the world? Not necessarily. A language model's knowledge comes from its training and from whatever additional information or tools it has access to. When a system has access to web search or other tools, it can retrieve current information. Without those tools, it may not know about very recent events. That's why AI systems can sometimes give outdated or incorrect information. Another interesting problem is hallucination. Sometimes an AI model can generate information that sounds convincing but is actually wrong. Why? Because the model is designed to generate likely language. It isn't automatically checking every statement against reality. If the model doesn't have reliable information, it may still produce an answer that sounds confident. That's why important information should be verified. AI can be incredibly useful, but it isn't perfect. Now imagine scaling this entire process up. Instead of generating a short answer, the system might analyze a long document. It could summarize information, translate languages, write code, analyze data, create explanations, or help with complex research. All of these tasks rely on the same basic idea. The AI processes input, calculates patterns, and generates an output. And the technology behind this process is constantly improving. New models are becoming better at reasoning, understanding different types of information, using tools, and working with text, images, audio, and other forms of data. Some modern AI systems can even combine multiple capabilities in a single model. This is changing the way people interact with computers. For decades, humans had to learn how to communicate with software. You had to understand menus, commands, and programming languages. Now AI allows people to communicate with computers using ordinary language. You can simply describe what you want, and the system can attempt to understand your request. That's a major shift in computing. But the most impressive part may be what's happening behind the scenes. When you send a simple question, it may look like you're just chatting with a website. In reality, your request can trigger a huge amount of computation inside powerful data centers. Your text is converted into tokens. Those tokens are processed by a neural network. Millions or billions of mathematical operations are performed. The model predicts the next tokens, and the final response is sent back to you. All of that can happen in just a few seconds. So the next time you ask ChatGPT a question, remember what is happening behind that simple text box. You're interacting with a massive mathematical system trained to recognize and generate patterns in human language. It doesn't work like a human brain. It doesn't simply search a database for a perfect answer. And it doesn't magically know everything. Instead, it uses neural networks, parameters, attention mechanisms, enormous amounts of computation, and sophisticated training methods to generate useful responses. And this technology is still developing. The AI systems of the future may become faster, more accurate, more capable, and better at understanding complex tasks. We are still in the early stages of this technology, and the way we communicate with computers may never be the same again. If you enjoyed this video, make sure to like the video and subscribe to the channel. Turn on the notification bell so you don't miss the next video. Thanks for watching, and I'll see you in the next one.